Welcome to the course introduction for Introduction to Java 7 and Object-Oriented Programming. My name is Randall Nagy, and I'll be your instructor for this session. In the beginning, we're going to start with the course description that'll tell us a little bit about using Java. Keep in mind, however, this is an intensive hands-on approach, so we do tend to go a little bit farther than most beginning students are used to doing. We're going to cover techniques and topics that are not only new to Java 1.7, but also might be new to many professional software developers out there. So with a little bit of effort on your part, I think you discovered that not only are you getting training that'll teach you how to use Java, but perhaps allow you to teach old Java software developers a thing or two about what's new in the software development world today. Of course, we also take the approach of a real-world evolving set of requirements. Requirements are very important in our world because we need to make sure that we're doing what is required of us. Once we have requirements, of course, it's a matter of documentation, and the way we document doesn't really necessarily have to be the same way for all software developers, but we should be very focused on making sure that we are doing exactly what is required of us. So we begin to start talking at a basic way of doing Java that requires us, note the word requires us, to process input in such a way that we're producing some output on a console application. We're going to over and over again use the input, output, and processing pattern because honestly, that's what every software development technology does to make sure it's adding value to what our users and managers are expecting of us. Of course, when we're using Java in general, we have to cover the basics, and the basics include using primitive types and keywords and classes, all of which you're probably not familiar with at the moment, but you will be by the time this training is done. But simply using these capabilities to create Java classes is just the beginning of what is required to become a Java software developer. Whenever we begin to use these capabilities, we discover that we're creating our own ways to extend Java by making classes and other interfaces and arrays that actually power the creativity process so that others can use it as well. Once we therefore cover the basics of Java, a good deal of what is required to become a professional software developer is to creating our own frameworks, which includes commonplace and easily understandable ways of making objects that other people can inherit from and power what we create for them. So ultimately, we have our own frameworks that allow us to create and manage groups of objects. So we really have to cover Java templates, arrays, as well as what happens when things go wrong in Java, known as exceptions. As a result of taking this course, you will be able to understand as well as perform the basic operations required to manage our processing of anything that we need to do with Java. Of course, this will require using keywords and concepts that are very succinct, but also are the basic building blocks upon which we must use the Java grammar to create more sophisticated classes and objects that other people might use. Along the way, you might discover some very interesting terms that you might not be familiar with, terms like exceptions, boxing, and unboxing, and we'll make sure that you have an introduction to these keywords and technologies. But at some point in time, keep in mind, it's all about practice when you're a software developer. So take what we give you, find a problem that you need to solve, and go a little bit farther. That's the key to actually becoming part of a Java professional. We're going to then allow us to discuss the new innovations with Java that include generics, using the Java collections framework and creating arrays that move groups of our objects back and forth between all of our frameworks and the work of other people. At some point in time, at the end of the day, becoming a professional software developer is all about creating objects that leverage the polymorphism and encapsulation and the relationships between what we call across all programming languages as object orientation. You'll discover that when you become an object-oriented programmer, that you begin to start looking at the world a little differently. In other words, you're looking for nouns and verbs or objects that we can use in our programming creations. Creating our frameworks from all of our objects is, of course, the final test of being a Java software developer. Understanding the mechanisms behind Java and how it uses classes, inheritances, and interfaces is just the beginning of what is required to understand the mechanisms that we need to create frameworks that other people can use as well as add value to over time. Managing Java's objects using the built-in capabilities of arrays, templates, and collections is one of the very important objectives of this training. The course prerequisites are simple, but keep in mind, although this is an introduction to programming for non-Java programmers, we do have to understand the basics of using our computer and be comfortable with using files on a file system. Also remember that Java is a trademark of Oracle Corporation, and using Java as well as the tools we're going to be talking about often requires registration and acceptance of terms that you will find in the lab exercises themselves. So what are the beginning module topics? We're going to begin by discussing what programming is. We're going to define the need to input and output and process data in such a way that we can leverage Java tools and technologies, certainly variables, packaging, and messaging, so that we can review the basic keywords and types that are part of the Java programming experience. The primitive types, of course, have their own ways of working together to use logical operations that eventually allows us to use them succinctly in classes. Classes are a unique way of defining and extending the basic capabilities of Java. And to tell you the truth, creating your own classes is pretty exciting. It's a good deal of what people like about writing software in general, because we're creating little pieces of reuse that we can access and reuse in other applications as well. Once we have, of course, a single object, putting them together at some point in time requires that we review arrays and operators that allow us to create groups of capabilities that themselves, because a lot of the operations we have in arrays will actually introduce us to more operations and collection classes that actually become important. So at the end of the day, once we've covered the basics, it's all about class relationships and object-oriented programming. In other words, how does one class relate to another? It's not uncommon when we're writing software to have a factory class, we could call it a car factory, that actually has a relationship with things like cars being put together, as well as orders for those cars, perhaps even of components in those relationships themselves. For example, engines, doors, and other analogies. All of these class relationships come down to managing the keywords and classes that relate them together, not only in such a way that we understand that, for example, a car has an engine, but allow us to understand that our classes can be named car, engine, and have operations that pertain to the operation of not only the car itself, but there's the engine as well. All of these capabilities, in other words, allowing our Java classes to actually resemble something in the real world that other people can relate to, is what most people consider to be good object-oriented practices. In other words, where object orientation, or our object orientations, if you will, are such that we are writing code that matches the problem which we're trying to solve for our clients. Of course, once we begin to put together these relationships of business objects, we are putting together frameworks that allow other people in the future to come behind us and create objects that perhaps we didn't think about. Oftentimes we discover, for example, when I'm creating a factory for cars and we have a factory pattern that has order entries and manufacturing processes, that perhaps we can extend those relationships to doing things with ships, airships perhaps, or spaceships. It's all a matter of allowing people to come into our frameworks and use some of the new techniques, not only including the objects that we're going to talk about, the primitive relationships, as well as the inheritance relationships, but can use more recent innovations, for example, like Java enumerations. Of course, we're going to cover Java arrays. That's the basic way we collect and manage groups of objects, whether they're groups of factories or groups of cars or orders within a factory. But sooner or later, we're going to cover the new way of doing business with Java collections or the Java collection frameworks. Over time, we'll discover that having things not go the way we want them to go will usually come into a discussion about Java exceptions. So keep in mind, this is a beginning course, but it also assumes that we have the fundamentals of operating systems completed. In other words, we understand things like processes and threads, and more importantly, how we would use those in our operating environment. We, of course, will be talking about processes and threads in this training, But we also assume, starting out, that you are not a software developer, but of course you understand the basics of what an operating system is doing. The next concept, of course, will be taking what we've learned about the basics and move them into what we need to do to become an object-oriented programmer. Over time, I've discovered that advanced Java programming allows us to use the keywords and techniques that other software developers, even those who have been around for many years, might not understand, and we'll be covering a lot of that in our training footprint as well. The materials to download for this training include the student guide. Of course, the student guide is your first line of defense to understand and review what we'll be talking about on the screen. Next will be our exercise guide. Our exercise guide, of course, will have the practice that we need to allow us to actually begin to get some hands-on experience with what we'll be talking about in the lessons. Finally will be the lab files. In the lab files, we often have a starter file, a file that you can import to your integrated development environment, or IDE, that allow us to get started without doing a lot of tedious setup. But more importantly, what the lab file has in it is a solution file, which I encourage you to look at only after you have absolutely done your best to complete the exercise file. A good deal about what it takes to become a software developer is to get that muscle memory, or the ability to not only key in the files, but know when and how to use your integrated development tools to find answers to your problems as well. The lab exercises themselves, I would encourage you to use as a template, if you really want to become good at software development, to create your own exercises, your own input, output, and processing paradigms for tools and technologies and projects that you find interesting in your way of solving problems. It could even be a game. So let's get started. Let's discover how we can not only learn Java, but begin to appreciate what it takes to become a professional software developer.